So let's start with our new topic, that is inverse proportion. Uh, it's basically opposite of direct proportion, and what happens in an inverse proportion is, if you remember the direct proportion, that if x is directly proportion to y, so it's going to be written as x is proportional to y, which is equals to something that is a constant, a constant rate. If one thing is increasing, the other thing is also increasing. If price of one shirt is 100, so price of two shirts will be 200, price of three shirts will be 300, and so on. If one thing is increasing, the other thing is also increasing. But in inverse proportion, it is totally opposite. It is opposite inverse. If one thing is increasing, other is decreasing. For example, let's take example from our book only, that is on page number 19 of book 2. It says table 1.6 shows the time taken for a car to travel a distance of 120 kilometer at a different speeds. Yes, their speeds is mentioned in x kilometers per hour and time taken y hours. Now, if speed is 10 kilometers, it's going to take 12 hours. Speed is increasing 20 and time is decreasing. Then again, speed increasing, time is decreasing more. Increase, decrease, increase, decrease. The more it is, the speed increasing, it's going to take lesser time. And it is pretty common sense that it's going to, if for example, if I take an example, if one person is doing a project in 2 days, if that same project two persons are doing, so it's going to take lesser days, obviously. So it's inverse proportion. But we have to keep in mind that speed of both those two person who are doing the project is the same. Now let's study these examples again. If the speed of car increase, will the time taken increase or decrease? Obviously, speed is increasing, time is decreasing, so it's going to decrease. If the speed of car is double, for example, first it was 10, double of 10 is 20. If it is doubling, so what we are noticing, that the speed is, time taken will be half. Here, if 20 double is 40, so time taken is 3 hours, so it's going to be half of this time, so it's going to be half. So if speed is doubling, the time is becoming half of the other time. So I hope this is clear. And then we use a formula to find inverse proportion. If we say x is inversely proportion to y, it will be x is inversely proportion to y, means the opposite. So it's going to be also equal to k, or we can write down it as x equals to k upon y, or xy equals to k, means these two are inversely proportion, so they are going to be multiplied together, and once x and y will gives you a constant k. K is constant. And this is going to be used throughout our exercise 1C.